I was like wishing I had a time machine and I could go back to myself and like punch myself in the face. Actually, it wasn't even like say no. It was like physically remind myself that I didn't like to do that.
That was organic chemist Sarah Reisman on the subtle way she sometimes wants to remind herself not to take on tasks she doesn't enjoy.
Everyone has to deal with things they don't want to do at work. Chemistry professors have a little bit of freedom on what projects they choose to work on. The flip side is that they also have to deal with a lot of outside pressure on what those projects should be.
In this episode of Stereochemistry, we're hearing from two powerhouse professors of organic chemistry, Sarah Reisman at the California Institute of Technology and Melanie Sanford at the University of Michigan. I'm Carrie Jansen.
And I'm Atabey Rodriguez Benitez.
Sarah and Melanie recently sat down with C&EN Associate Editor Leigh Boerner to discuss making your life as an organic chemist the one you want and how to enjoy both the journey and the destination. Welcome to the show, Leigh.
Thanks. It's lovely to be here once again. I'm last this season.
Yes. This episode is the final installment in our current series. Make sure you stick around until the end of the episode to hear what's up next for stereochemistry.
I'm bringing the champagne.
Well, before we pop the bubbly, we have a lot of great stuff to share from Sarah and Melanie. So, Leigh, why do you want to get these two together in the first place?
Well, Melanie and Sarah have a lot in common in that they're both organic chemistry professors, but they do different flavors of organic chemistry. Melanie leans more organometallic, which involves molecules that have both metal atoms and carbon atoms like you would normally find in an organic molecule. She works on a lot of different projects involving catalysts, such as CH functionalization and fluorination chemistry. And while Sarah also plays with catalysis chemistry, she's mostly known for doing total synthesis of natural products.
Natural products. So that's making these crazy complex molecules that are only found in nature, right?
Right, only found in nature in very small amounts, and that have some property that could make them potential drugs or antibiotics or other valuable bioactive molecules. Some organic chemists want to find ways to make these molecules in larger amounts so they can study their properties.
So even though they are both considered organic chemists, their research is pretty different.
Yeah, and there are some other ways in which their research diverges, which we'll talk about more later. But they have a lot of overlap, too. The world of organic chemistry is not huge, and, still in 2022, there are not many women in the discipline. So yeah, they've known each other for a while. During our interview, I asked them if they could remember when they met. Melanie answered first.
I don't know if it's the first time we met, but my most distinctive early memory of Sarah is when we interviewed her for a position here at Michigan. What I remember most distinctly is when she came back for her second visit, and there was like a little dinner party. And, I remember talking to Sarah and trying to convince her to come to Michigan. And I also remember that it was like late January, early February of 2008. And my son had been born like a month earlier. And I was like fried. I mean, I think it was the first event that I actually left the house for since he was born. And so I just remember being so overwhelmed with everything, but yet really wanting Sarah to come. And so trying to convince her, but being completely frazzled at the same time.
Yeah, I was going to say, I also thought it was when I interviewed at Michigan, and remember actually you being quite pregnant when I interviewed and having had the child, between when I initially interviewed and then when I returned. And I think for me, what I remember actually is when Melanie came to visit Yale when I was a graduate student. And it was when you were, I think, interviewing for jobs yourself at that point. And I remember seeing your job talk at Yale.
Yeah, no, I remember that interview at Yale. And I was an undergraduate there, right? So I remember that very clearly because it was like every meeting was with a faculty member that I'd had for like a class or, had been a mentor in some way. And so it was super intimidating. I remember the proposal presentation. I was like, it's going to be so stressful. I need to figure out a way to make it less stressful. So I said to them at the beginning of it, I said, I know you guys are going to ask me a lot of questions and I'm probably not going to know some of the answers. So you guys can just all remember that when I don't know the answer, it's actually, your fault. And then there was like silence. And then they were like, oh, 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 oh. And I was like, oh, phew, at least my joke didn't bomb.
As we know now, Melanie decided to take her burgeoning comic career to Michigan rather than Yale, and Sarah chose Caltech when it was her turn. But both have been running their own labs for many years now.
Right, and like most professors, they have to manage a lot of different aspects of their job at the same time. their research, their students, teaching, writing grants, writing papers, and so many other things. Personally, I am crap at keeping a bunch of balls in the air at once. I'd be dropping them constantly.
And you are not alone in that, Leigh. Even very successful chemistry professors like Melanie and Sarah drop some from time to time.
Yeah, and that's something that I asked them about. I wanted to hear how they manage priorities and how they deal with setbacks.
Well, how do you get out of that then when you feel like you're failing? How do you kind of boost yourself back up? How do you keep going?
Compartmentalization.
Exactly.
There are more tasks to do than there are time to do them.
Yeah.
And the good thing about that is that it means that you don't have too much time to dwell on the things that are not going well. You just move on to the next and then circle back. At the end of the day, there's always something still to be done. And I think at some level, I have learned how to just, forgive myself.
Right. Let it go.
For not maybe doing things quite as quickly as I want to. And then it gets me thinking about what things can I do with my lab so that papers come in at a stage where they can get turned around more quickly. How do we take general lessons and make sure that our first draft that comes to me hits at a level where there's less back and forth going on? Or what can I do to make sure we're running the right experiments? Because I definitely feel like every year I am learning how to do this job better. And, there are times where I start to feel frustrated and then I'm like, well, what can I do? What proactive measure can I take so that this doesn't happen next time?
Totally. So I guess my question is how do you decide what to say yes to? What goes into you making a decision about that?
Well, I think for a long time, as I'm sure was true for you probably at some part in your career, you say yes to just about everything.
Exactly.
You're
right.
like,
Yeah.
Well, you're getting asked and how do you say no? And so I've started to try and be more selective in the last several years. And I think it gets easier to start saying no once you feel like honestly at capacity, right? Somebody reminded me that you don't want to say no to things that you like just because you feel too busy, and that it's more important to say no to things that are not rewarding. And so I'm trying to prioritize a few things like related to, say, women in chemistry or diversity, equity, inclusion more generally. I do think those are important and rewarding if you're on the right kind of committee that can make changes. But I'm less interested in being on a committee just because they were looking for one more person that fits a certain demographic to be there. And if I don't think it's actually going to, there's no power to that committee, or there's no action item that it feels like is going to get done. I think I still need to say no more often.
For sure. Yeah.
I feel like my lessons learned are when I have said yes. And then after a year, I'm like, oh my gosh, what am I doing? I hate this task. Then I sort of write that down as a thing that I want to make sure I don't say yes to again, that type of committee or commitment.
One thing I really like is to be on committees where my voice will be different than the rest of the people. And when I can say something that makes people look at something from a different perspective, or convince them that this assistant professor, for example, is actually doing really great stuff, and have them elevate that person and ultimately they win an award, that to me is really cool. So I try to be on things where I feel like I can be an effective advocate, because that's where you can really make a difference, I would say.
For a lot of us, learning what to prioritize and what to let go is an ongoing journey. Figuring out what to say yes to is a big part of how both Sarah and Melanie steer their careers into territory they find rewarding.
Yeah, and I was really curious about what fires them up, research-wise. And they each had a different answer to that question in a way that kind of reveals another important way their work differs in focus. Let me see if I can explain. Atabey, you like to bake, right?
Yeah, another pandemic hobby I acquire. Why?
Well, when you bake, which part do you most enjoy? The actual act of baking, like combining the ingredients, or whatever baked good comes out at the end?
Well, I like what I get at the end, when it tastes good, that is. But I think I like the process itself a little bit more. For example, I really love the process of maintaining a sourdough starter. Although it's funny how even if that process is simple, just adding water, we can still mess it up. Ask my recently deceased sourdough starter.
Okay, so you're mainly a process baker. I also like to bake, but I'm more interested in my product, like what tasty things I get out after it's all done. So I am the 9 millionth person to compare chemistry to baking, but chemists fall into these process versus product categories too. For Melanie, what she makes is important, but how she gets there is what she really focuses on. She's a process chemist. Sarah is the opposite. She told us she definitely appreciates the process of synthesizing molecules, but at the end of the day, she's most concerned about what's coming out at the end. She's a product chemist, also known as a target-directed chemist.
Ah, got it. So Melanie likes baking the bread, but Sarah is more focused on the finished loaf.
Exactly.
Okay, so now that we've stretched this analogy to its breaking point, Leigh, let's go back to your question about where Sarah and Melanie find their research inspiration.
Right. You could get a sense of the different approaches each of them takes from the way they talk about their work. Here's Sarah.
Well, I'll say my favorite thing in a project is when we have a plan for a synthesis and there's something unexpected that happens, and then we can use it effectively. Like we can actually make our approach shorter because of this unexpected discovery or rearrangement or something like that. And then you're like, oh, that solves our problem. And we can take advantage of this and sort of develop it in a creative way that we didn't expect. And it takes a special student who can like recognize that and not just get disappointed, but see that the unexpected is actually a better direction to go.
I would totally piggyback on that. It's almost exactly the same thing, except the reason that I like not doing target-directed synthesis is because my favorite part of research is when something unexpected happens that's way more interesting than what you were trying to do originally. And then because you don't really care what you were trying to make at the end of the day, you could just do that and it's even more awesome, you know? So I think that for me, that's what would be hard about doing what Sarah does is like at the end of the day, you want to make your molecule. And I'm so easily distracted and I think something is cool and I want to pursue that. And so for me, it's like getting back to the target would be very difficult.
How did you each get interested in the fields that you're in now?
You know, for me, I've always just been drawn to these types of structures and molecules, just wanting to think about how you put them together. I see a structure and I just start thinking about like, how do you make this? What bonds should you be trying to make? What types of reactions can you think about from a strategy level?
For me, I saw organic chemistry as sort of a series of like very well-defined rules. And I think what attracted me to organometallic chemistry is I was like, these metals are amazing. They can do anything. You know, there's no rules, or at least the rules, like I don't understand them and I want to, you know? So I guess for me, it was more like the wonder of going through organic chemistry and seeing how everything, of course it wasn't, but as an undergraduate seemed like totally worked out. Like everyone knew exactly how things were going to react and where the arrows went. And then you get to organometallic chemistry and it just like blew my mind that these crazy things could happen and you just never knew what to expect. And so for me, that's what sort of set me on the path to thinking about metals and organometallic chemistry.
Seems like that would scare a lot of people off, though. Like all of a sudden, look at all these d orbitals and there's f orbitals, just like all this crazy stuff that can go on.
But so I guess the way I looked at it was more like anything could happen. Like you could put these reactants in and anything could happen because there's D and F orbitals. It almost seemed like you could never predict, or at least something could happen and you would just be totally blown away and never have expected it. And to me, that's like the discovery component of science that I thought was really cool.
As you can hear, Melanie is pretty excited about metals, and that's in part because of her background, which is a bit off the expected reaction pathway for an organic chemist, so to speak.
So my PhD from Caltech is actually in inorganic chemistry. So I guess I have always felt a little bit like a outsider, maybe in the field of organic chemistry. When I was applying for jobs, I thought I would just apply for inorganic jobs. And then I was really surprised when people sort of viewed me as an organic chemist. I always hear people say that organic chemistry isn't that inclusive of a field, but actually, at least in terms of the sort of research component, I felt that I was embraced by organic chemists almost more than by inorganic chemists when I first entered my independent career.
Well, does it really matter if Melanie doesn't have the same background as most organic chemists? Will other organic chemists view her work differently because of it?
Yes and no. It used to matter, but according to Melanie and Sarah, that's not so much the case anymore.
Next up, we'll hear Melanie and Sarah's thoughts on what organic chemistry is and how that field may be changing. That's after a short break.
Hi, Arminda Downey Mavromatis here. I work with C&EN's audience engagement team, and I am thrilled to tell you about our latest newsletter, Selling Your Science, the Art of Science Communication. Honestly, science communication is the job of every scientist. Over the course of your career, you'll need to be able to speak about your science to a wide variety of audiences outside of your specific area of research. Every Thursday, over the course of 6 weeks, we'll send you advice from one of our guest hosts on topics including how to sell your science to your friends and family, how to create an engaging research poster, how to give an engaging research talk, how to get your science in front of journalists, how to win research funding, and how to create a website to showcase your work. You can sign up now at cenm.ag/science communication. Again, you can sign up for C&EN's Selling Your Science, the Art of Science Communication at cenm.ag/science communication. We'll include that link in the show notes on C&EN's website. And now, back to the show.
In the first part of the episode, Melanie and Sarah talked about why they got into science and how they approach setting priorities. Next, we'll pull back a little bit and look at the field of organic chemistry overall, what the field was and is, and what it might be turning into.
So our discussion touched on a big question for some chemists today. What is organic chemistry?
If you ask 100 chemists that, you will get 100 different answers. For some people, an organic chemist should be able to rattle off all the big named reactions, while others challenge the emphasis on named reactions and argue for different ways to measure competence. But Melanie and Sarah told me that they think this thing we call organic chemistry is going through a bit of a makeover.
So, you mentioned that organic chemistry has not been, super inclusive in the research way. Do you think that's changed?
Organic chemistry has a reputation. I guess my perspective was that I never took a synthesis class. I didn't know all the named reactions. I still don't know most of the named reactions. And so I just felt like organic chemists would just look at me and be like, you're not a real organic chemist. I guess I don't usually tell them that I don't know all the named reactions. So maybe they just don't know, But I found that people were really welcoming and they thought that I was bringing something different to the field and that it was valuable. It's just not what I had expected. But I guess I just realized that a lot of organic chemists, at least, have a pretty broad view of the field and what organic chemistry is and what interesting contributions to it can be. So I don't know what Sarah thinks about that because she's positioned differently relative to the field.
I guess I would say I do think that there are a lot of reputations about organic chemists that I like to think predate us, and about synthesis and how people connected or valued different contributions within organic chemistry. And I do feel like there's less of this is an organic chemist, right? This flavor of organic chemistry is the only flavor. I think, people have moved in different directions. And I think that's a good thing. And maybe it's because we have to start branching out, right? It's like you have to keep moving the field forward. And I think that requires sometimes looking at other disciplines and the types of tools they're developing and asking, how do you bring that into organic chemistry? Or asking, what kind of problems are they solving that we are uniquely set up to do? That's how we continue to do interesting chemistry, I think. So I'd like to think that it is broadening in terms of the definition of what's organic chemistry. Or maybe it's just not important that it's like everyone gets stamped as a card-carrying organic chemist or not. I don't know.
My sense is that pharma is actually helping with this lately. When I started my career, they would invite me for a seminar. We'd have a really nice day. They asked me all these questions about all my reactions, right? And then at the end of the day would tell me, we would never hire one of your students without a postdoc because even though they were very interested in what I was telling them all day, they were like, well, the person really needs to have done more synthesis, before we would hire them. And I feel like now they are recognizing in a way that I think is really great that like having people with different perspectives actually is super valuable to the overall enterprise, and that everyone having training in total synthesis maybe isn't the best way to go. Certainly you need those people, and you also need people that know how to do catalysis or know how to do various different kinds of things. So I think that's been good and something that has certainly changed during my time in the field.
So why do you think that's changed? Like what set that off?
part of it is that in some ways, because of this sort of constant migration of catalysis and organometallics and different types of chemistries into the arsenal of the organic chemist, right? That it can be really helpful to have chemists with expertise in different areas, right? And just realizing that if you are going to be using the most modern methods, let's say, to make a molecule, then having people who were involved in the development of that chemistry can be really helpful, right? And that's not just coming out of one group, right? That's coming out of lots of different labs.
Yeah.
So it comes back to this idea that they want to have a team of people who think about a problem from different perspectives.
As Sarah and Melanie see it, this shift means that the chemistry community is more likely to produce good products and have a good time getting there.
And if we can all figure out how to set healthy boundaries, we'll really be making progress.
Right. And I hope listeners can find some takeaways in what they share about managing priorities, even for those of us who aren't managing an organic chemistry lab. That's definitely one of my goals this year, to not say yes to everything. Maybe then I'll finally have some time to really nail my sourdough and maybe bring it back to life, maybe.
Something we can all aspire to. You can read more about the exciting work coming out of Sarah's and Melanie's labs on C&EN's website, cen.acs.org. We'll link to some stories featuring them in this episode's show notes on our website.
Carrie, didn't you say you had a message for our listeners about what's coming up next on Stereochemistry?
I do, yes. As we mentioned, this episode is the fourth and final installment in our current series, which features sensational chemists in conversation with each other. We heard from you that you love this style of episode, and frankly, we like making them, so we'll definitely have more episodes like this coming your way in the future. We even came up with a special name for them. We're calling them C&EN's Bonding Time.
Of course it's a chemistry pun, because of course it is.
You'll still find those episodes right here in your Stereochemistry feed, kind of a show within a show. If you'd like to suggest a sensational chemist or two to be featured in C&EN's Bonding Time, let us know by emailing cenfeedback@acs.org. We'll have more details for you on those upcoming episodes soon. First, however, we have a different story to tell. The next season of Stereochemistry will explore the future of water. What does that mean? Well, C&EN's reporters are digging into that question at this very moment. And we'd also like to know what questions you have about the future of water. No question is too big or too small. Again, you can email us at cenfeedback@acs.org. Our contact info is included in the episode's show notes as well.
And while you're waiting on new episodes, you can whet your palate by revisiting our episode for this season with environmental engineers Jessica Ray and William Tarpey. We've heard how they are thinking about the future of clean water, and they also share how they have learned to thrive as assistant professors.
Thanks for listening, and we'll see you soon.
This episode was written by Leigh Krietsch Boerner and produced by Carrie Jensen. Study editing by Michael Torres and Amanda Yarnell. Production assistant by Gina Vitali.
The music in this episode was A Train on a River by Dialgo and Different Kind of Love, instrumental version by Anthony Lazzaro. The promo music was Plain Loafer by Kevin MacLeod.
Stereochemistry is the official podcast of Chemical and Engineering News. C&EN is an independent news outlet published by the American Chemical Society. Thanks for listening.